In this video, we're going to continue our work with multiplication of polynomials, and we're going to talk about two special products that involve binomials, multiplying binomials. And the first special product is called multiply the sum and the difference of the same two terms. So, for example, look at these three problems that we're going to be talking about. Notice that for each one of them, you have two binomials that are being multiplied together. The binomials have the exact same terms, but the signs are opposite. So in one binomial you have the sum, and in the other binomial you have the difference of the same two terms. And it's interesting what happens with this. So let me just do this first one with you using our FOIL method, and then I'm going to talk to you about the shortcut on how to multiply this special product. So with the FOIL method, we know that we would be multiplying the first, which would be x times x, or x squared, and then we would multiply the outer terms, which would give us a negative 10x, and then we would multiply the inside terms, which would give us a positive 10x, and then we would multiply the last two terms, which would give us a negative 100. And so here's what I want you to notice, that when we have the sum and the difference of the same two terms, that in the middle with our outer and inner products, we get the same terms but opposite. So notice how we have a negative 10x added to a positive 10x here. So those two terms are going to give us 0. And our final answer for this product is going to be x squared minus 100, which is what we would get if we had looked at the original problem and squared the first term. So square that x, okay, minus square the second term. Square the last term. Let's call it the L for last. So we would get x squared minus 10 squared, which is x squared minus 100. Okay, and that's a special product. Matter of fact, it's so special that we give this sum and difference their own name. We call these two binomials, they have the same two terms, but one's a sum and one's a different. So a plus b and a minus b. So we call those binomials conjugates. Same two terms with a different sign. Okay? When we multiply conjugates together, we will get the difference, so a subtraction, the difference of both terms squared. So how are we going to use that? Well, let's use it in number 2. So again, we have here a sum and a difference. So we have here conjugates because they are the same two terms in the binomials, but one has a plus as a middle term and one has a minus as a middle term. Call those conjugates, and according to our special product, we should be able to square the first term minus square the last term. So square the first term minus last term squared. So when we square the first term, we get 36x squared minus, and then 5 squared is 25. And our middle terms, we showed you in the last problem that when we FOIL these two binomials, when we use distributive property to multiply, that the two middle terms give us 0. They're exact opposites. So now we can bypass that. We can just use this shortcut. Now I'll tell you that your teacher, your math instructor, might be just fine with you using our FOIL method to multiply. But in the next chapter, we're going to go backwards. We're going to have to recognize this kind of answer where we have the difference of two squares, and we're going to have to come back to the original problem, to the original two binomials, and that's called factoring. And so that's where we're headed, and that's one of the reasons we'd like to introduce this special product to you now. Okay, number 3, once again, we have conjugates, don't we? We've got two terms, two binomials where the two terms are the same but the signs are opposite. One's a plus and one's a minus. And so according to our special product, we should be able to square that first term minus square that last term. And squaring d squared, we know that's a power rule, so that will be d to the 4th minus, and 1 squared will be 1. Now in these next three examples, you're going to notice that we are taking a binomial and we're squaring them. Do you see that? You've got binomial and we're squaring that. Squaring a binomial. Now, I'm going to warn you here that some students, they want to just square the 2x and square the 6 and call it done. But that does not work when we're squaring a binomial. And I'm going to show you why, because we're going to FOIL. If we're going to FOIL, it's good to rewrite the problem. So we're going to write the problem, expand it, just like that. And then we're going to FOIL. So we'll go 2x times 2x, which is 4x squared. Then we do outer terms. That will be 2x times 6, so that's a plus 12x. And then when we do the inside terms, we get another 12x. So we get two of those. The two middle terms are the same. That's a pattern that you're going to want to see. And then for the last terms, we're going to take 6 times 6, or 36. So I want you to see that we do end up with this middle term, that's 24x. So squaring a binomial, you will get a trinomial. You will get 3 terms as an answer. So you want to be really, really careful when you see these binomials to be squared that you get 3 terms. Now I want you to see the pattern. So the pattern is this. The 2x, to get to the 4x squared, we squared it. 2x got squared for the first term. And then the 6 got squared for the last term. So 6 was squared for our last term. The middle term is twice, so double, twice the 2x multiplied to the 6. The 2x multiplied to the 6. So you took the two terms that were in the parentheses in the original binomial, multiplied them together, and double that. And that gives you the middle term. So we're going to use that pattern in our second problem, but I'm also going to show you that our box, that's what the box says here. It says that if you're squaring a binomial, the first term will be squared, the last term will be squared, and the middle term will be twice the product of the two terms. Okay, and that works both for a sum or a difference. So we're going to use that pattern here with problem number 2. So we take the first term and we square it. And we take the last term, but leave some room there. The 5, we square the 5. But our middle term will be negative because these signs will match, and you're going to take double the product of these two. So 4x times 5. So the middle term is always double the product of the two terms in the binomial, and you've already taken care of the subtraction of the sign, so you don't have to worry about the sign. So let's simplify here, and we get 16x squared minus, so we have, this guy is 20, isn't it? 20x. We have there 20x. So 2 times 20x is 40x. And then plus 5 squared, which is 25. So now look at number 3. We are squaring two binomials and then subtracting them. So what do you think we do first? Yep, we're going to have to do this squaring part first. Now, let's do one at a time. As a matter of fact, let's split this up. We're going to first square the x minus 7, and then we're going to square the x plus 9, and then we will subtract. Okay, just to keep everything clear. Again, we're going to take our first term, which is x, and it gets squared. So that's x squared. Then we're going to take the last term, which is 7, and we're going to square and just leave some room. So that's 49. Our middle sign will be negative because these are going to match, right? And now we take double the product. So multiply 7 times x, and we take double that, so 14. So here we get x squared minus 14x plus 49. Okay, well, let's do the next one. X, we're going to square that. The sign's going to match with a plus. We want double this product, 9 times x, double that, plus, and then we're going to square the 9, 81. So we get x squared plus 18x plus 81. Okay, we're halfway there because now we have to subtract these two. these two trinomials. So we have x squared minus 14x plus 49. And then we're going to subtract. I'm going to put them right under here because they have like terms. But we want to subtract, which means we have to change all these signs. So that becomes minus, minus, minus. So all three of those become negative. Let's make them negative. So minus, minus, minus. Okay, you got to be careful there with the signs. That's the hardest part of this whole problem is this subtraction right here to get those signs right. So now the x squares are 0, and here we get negative 32x, and here we get negative 32.